Hello everyone, welcome back to DevOps Interview Series. I am Ashwini, and in today's episode we are going to learn one of the most important skills every DevOps engineer must know, that is Kubernetes troubleshooting. Let's get started. In real projects, creating deployments is only half job. The real challenge is when something is going wrong. Your pod is not starting, application is crashing, and your service is not reachable. You are expected to identify and do the RCA. So in this video, we'll walk through a structured process that you can use in production and also tell this in your DevOps interviews. We'll understand troubleshooting in Kubernetes. Troubleshooting is a process wherein first step is identifying the issue, then analyzing the entire situation, fixing the problem, and the same is applying in the Kubernetes cluster also. Few of the most common issues that we face in production are pods getting stuck, certainly in the pending state, the error type crash loop back off, image pull back off, services are unable to access by the user, services not accessible, DNS resolution failures, PV, that is persistent volume mount issues, and the nodes are not ready. Instead of randomly trying different commands, engineers who are experienced with these frequent kind of issues that occur in production follow a systematic approach to find the RCA, thus saving a lot of time and having the SLA in place. So we'll understand the workflow that we go ahead. Whenever a issue is reported, first of all, we do not panic. We have a simple workflow that we follow. First, identify which resource is affected. Check pod status. Use describe pod. It will give us the events that needs to be inspected. Review the logs, application logs. Verify networking is in place, services are proper. Check the storages. And finally, inspect the health of the nodes. This is a sequence that we follow every time, and it generally helps to solve problems much faster than randomly going up and forth in different steps. Essential commands that we need to use during the troubleshooting almost every day. Kubectl get pods shows the current status of all the pods. Describe pod gives detailed information of events, scheduling problems, image errors. Logs displays application logs. exec-it pod name bash allows you to enter container for further debugging. Some of most important other commands are get events, get services, get nodes. If you are able to remember these few commands listed here, you are already able to solve many of the Kubernetes issues. Most frequent faced issue is a pod is in pending state. Very common problem, pod is in pending. We'll understand why it happens, why it goes into the pending state. Cluster is not having enough CPU or memory. PV claim is in waiting state. Node selectors are not matching. Taints are preventing from scheduling the pods, hence it is pending. And there is no suitable worker node available. First command is describe pod. Then scroll down to the event section. And in the event section, you'll finally be able to see above, from the above, what is the exact reason why the Kubernetes couldn't schedule the pod and put it in the pending state. We'll see crash loop back off. What does that mean? It means application starting, crashing, Kubernetes restarting it, again crashing, again Kubernetes restarting it, crashing, and the cycle goes on and on. Hence, it is a loop. Crash, loop, back off. Common reasons include for this is there is configuration issue, environmental variables are missing, sometimes database is not getting connected, there are some bugs in the application, static commands are wrong. To check the exact issue, first check the Kubectl logs, followed by describe pod. Most of the time, the logs itself clearly indicate the root cause. We'll see image pull back off. Suppose Kubernetes is trying to download a container image. While downloading the image, there is an error that is visible which is stating image pull back off. What is the possible reasons for this? Image name is not correct. Image tagging is not correct. There is authentication issue or that image itself doesn't exist. Again, we'll use Kubectl describe pod. The event section will usually display the exact image pull error. Services not working. Sometimes pods are running perfectly, but still the application is not accessible. In that case, we will check the services. The commands that we use are kubectl get svc, kubectl describe svc, kubectl get endpoints, verify, label, selectors, pod, and target pod. If the service selector doesn't match the pod labels, traffic will never reach the application. And this is a very common interview question also. DNS troubleshooting. Applications inside Kubernetes communicate using DNS. If DNS fails, services cannot communicate with each other. To test the DNS run, we use the command kubectl exit busybox ns look Kubernetes default. So this is a command which, if the lookup fails, inspects the core DNS pods. Then we'll run the kubectl get pods in the kube system. So this will make sure core DNS pods are healthy and running. We'll see how to troubleshoot the nodes. Sometimes the issue isn't the application, it's in the worker nodes. How we'll check that? By using kubectl get nodes. So this will give us the node status. Then inspect the node with for the description by kubectl describe node. You can also check resource usage using kubectl top nodes and then look for CPU pressure, memory pressure, disk pressure, or node ready status. A healthy application depends on a healthy cluster. Okay, best troubleshooting was check resource status, describe the resource, read the logs, inspect events, verify networking, and so on. So, we have a quick interview takeaway right now. A skilled Kubernetes engineer don't memorize hundreds of commands, they follow a structured troubleshooting process. If you would have observed throughout all the troubleshooting, we were using kubectl describe, logs, events, services, and node diagnostics to identify RCA quickly and resolve production issues efficiently. If you explain this workflow confidently during an interview, it demonstrates practical Kubernetes experience. And that's it was for today's episode. I hope this video helps you understand Kubernetes troubleshooting works in real production environment. If you found this video helpful, Please like this video, subscribe to the channel, and share it with your friends preparing for DevOps interview. In next episode, we will continue our journey with another important production concept. Until then, keep learning, keep building, and keep growing. Thank you for watching, and I'll see you in the next video.